Hi everyone. In this video, we are going to discuss about mesh analysis, right? So main objective of mesh analysis is to determine the voltages and currents of the given network. That is the main objective. Mesh analysis is nothing but combination of Kirchhoff's voltage law and Ohm's law. That means mesh analysis is based on KVL and Ohm's law, right? So here, mesh analysis is based on KVL and Ohm's law. Okay, so let us discuss about the definition of mesh. Mesh is a loop or closed path without any other loops within it. Again, I repeat, mesh is a loop or closed path without any other loops within it. Okay, I'll explain this through circuit diagram. Let us consider a simple diagram. So plus minus, here this is voltage source. So one resistor, one more resistor. Now close the circuit. Okay, this is circuit 1. Now consider another circuit. So here again one resistor 1 and resistor 2, close the circuit. Okay, here one more resistor is there like this. Now see, so mesh is a loop or closed path. See, here closed path is there, here also closed path is there. Okay, here also closed path is there without any other loops within it. Okay, here there is no other loop inside this loop. Okay, any other loops inside it, but here this is the outer loop, this is outer loop. So inside this loop two loops are there, two other loops are there. Okay, that means here this is not a mesh. Very important, this is not a mesh. Okay, again I repeat, mesh is a loop or closed path without any other loops within it. Okay, these are the examples of mesh. This is circuit 1, this is circuit 2. So circuit 2 is not belongs to mesh, circuit 1 is belongs to mesh. Simple, right? Now let's see the few more points about mesh analysis. Now, so mesh analysis is used to determine the voltages and currents of the given network. Okay, and another important point, in analytical networks containing n number of nodes, b number of branches. Analytical network contains n number of nodes and b number of branches. Then the number of mesh equations is given by L equal to b minus of n minus 1, where b is the number of branches, n is number of nodes, right? I'll explain this point through circuit diagram. See, let us consider a simple circuit. So plus minus, right? Here a resistor, one more resistor, close the circuit, take another resistor, one more resistor. Now close the circuit. Now see, so here now see, from the given network, first identify the number of branches. So see, this is one branch. Branch means nothing but series circuit. This is one series circuit, nothing but one branch. This is another branch, second branch. This is third branch. Okay, so number of branches are 3. So number of branches are 3. So L equal to 3 minus, right? Now let us identify the nodes. From the given network, how many nodes are there? The given network, right? How many nodes are there here? See, node means always we prefer principal nodes. Principal node means interconnection of more than 2 elements, right? That means here interconnection of more than 2 elements. This is first node. Okay, this is second node. Simple. Interconnection of more than 2 elements. Number of nodes are 2. So from the given network, number of nodes are 2. Okay, so here now substitute 2 nodes. So b minus of n minus 1, that means 3 minus 2 minus 1. 3 minus of 2 minus 1. So 2 minus 1 is 1. So 3 minus 1 is 2. So number of mesh equations are 2. So L is denoted by mesh equations. Mesh equations are denoted by L. So number of mesh equations is equal to 2. Okay. So this is the explanation for this point, right? Now let us discuss about procedure to find the voltages and currents using mesh analysis. Let us see the procedure. Let's see the procedure here. Now see. So here steps involved in mesh analysis. So what is the step one here? So step one is identify the number of meshes of the given network. Identify the number of meshes of the given network. That is step one. Of course, I'll explain through circuit diagram, through numerical, I'll explain each and everything. Okay. So step two, assign mesh currents. Assign mesh currents arbitrarily for the mesh identified. Okay. Assign mesh currents arbitrarily for the mesh identified. Next, step number three, apply KVL to the given networks. Apply KVL to the given networks. That is step number three. Next, step number four, solve the system of simultaneous equations which are obtained by the application of KVL at each of the meshes. That is step number four. I will explain each and every step, okay, using numericals. So solve the, what is the step number four? Solve the system of simultaneous equations which are obtained by the application of KVL at each of the meshes. Okay. So let us consider one numerical. So in that numerical, I'll explain each and everything. See. Now here, example number one, first numerical. Now here, your question is, find the mesh currents I1 and I2 in the circuit below. Find mesh currents I1 and I2 in the circuit below, right? So this is the numerical. This is the diagram, circuit diagram, right? So here, so what is the step one here in mesh analysis? What is the step one here? First, identify the number of meshes from the given network. Identify the number of meshes from the given network. So see here, from the given network, okay, number of meshes. That means number of mesh equations. So what are the number of mesh equations here? So what is the formula? What is the expression for mesh equations? L equal to B minus of n minus 1. So L equal to B means where B number of branches, n means number of nodes. B minus of n minus 1. Okay, B minus of n minus 1. Right? Now see. So here, how many number of branches are there from the given network? This is branch 1. Okay, this one is branch 2. And this is branch 3. 3 branches are there. So 3 minus, okay, number of nodes are 2 nodes are there. Node 1, node 2. Okay, so 2 minus 1. 3 minus of 2 minus 1. That is number of mesh equations equal to number of meshes or mesh equation equal to 2. Simple. Right? Right. So step number 1. Step 1 is completed. Now here. Let us move on the second step. Now here. So step 2 is, so how many meshes are there? 2 meshes are there. Okay. So as per number of mesh equations, as per the given expression, 2 meshes are there. Now step number 2, assign mesh currents to the identified meshes. So what are the mesh currents here? So here, first mesh current is I1, second mesh current is I2. Simple. Okay, step 2 also completed. Next, step number 3. Okay, apply KVL to the given meshes. Okay, so apply KVL to the each and every mesh of the given network. At the meaning, apply KVL to the each and every mesh of the given network. Right. So let us consider first mesh. Now see, this is the first mesh. Okay, this is the current direction. So apply KVL to the first mesh. That means according to current direction, current enters negative terminal of 20 volts. So here negative terminal, right? First current enters negative terminal. That's why minus 20. Next plus. Okay. Current is always flows from high to low across passive elements. So here plus positive value, here minus. Okay. So current. What is the voltage across 3 ohm resistor means? Here KVL means sum of all the voltages around a closed path is always 0. So here voltage across the 3 ohm resistor means I into R. So what is I here? I1. That is from the given network, SN current is I1. So I1 into 3 ohm resistor. So that's why 3 into I1. What is the sign here? Positive. Sign is positive. Very, very important. But next step is very important. Now consider 6 ohm resistor. Okay. So here first mesh consists of 3 elements. What is the first element? 20 volts. Second element is 3 ohms. Third element is 6 ohms. Okay. Now consider 6 ohm resistor. Here also, as per KVL, I have to calculate voltage across 6 ohm resistor. Okay. So 6 into very, very important point. Listen carefully, all of you. Now here 6 into, now I can answer 6 ohm resistor, right? 6 into, what is the current here? In this element, in the 6 ohm resistor, two currents are flowing. In this element, two currents are flowing. The reason is this element is common between first mesh and second mesh. This element is common between first mesh and second mesh. That's why two currents are flowing through 6 ohm resistor, right? So that means here 6 into I1 minus I2. Okay, why I1 minus I2 here? Here let us consider 6 ohm resistor, for example. Consider 6 ohm resistor. 6 ohm resistor branch. So what is the given direction here? Current direction, current to I1 direction, this direction. This is I1. Okay. So I1 means here according to that direction, I1 is entering into the node. I1 is entering into the node. Okay. Now let us assume here this is the current flow I. Let us assume current is I passing through 3 ohm resistor. Okay. Downward direction. Now according to I2 direction, according to this I2 direction, now here current is leaving. So according to I2 direction, current is leaving here. Current leaves the node. Current leaves the node, right? That means now at this node, entering currents equal to sum of entering currents equal to sum of leaving currents at that node, according to KCL. So here I1 is entering, here I and I2 are leaving. That means here what is I here? What is I equal? I equal to I1 minus I2. Simple. I equal to I1 minus I2. I equal to I1 minus I2. Okay. So 6 into I1 minus I2 equal to 0. This is the KVL expression. Right? That means. Now, so this is the theoretical explanation. But here, no need to assume, no need to calculate each and every time. Not required. Now, see. So, if you here some assumptions are there. If you consider first mesh equation, that means this mesh equation. If you consider first mesh equation, or if you write first mesh equation, then assume first mesh current is more than any other mesh currents. Very, very important. If you want to write first mesh equation, assume that mesh current is more than any other mesh currents. Simple. Okay. That means here 6 into I1 minus I2. The reason is, now I can answer first mesh equation. So I want to write first mesh equation. That's why 6 into I1 is more than I2. Okay. For example, if you consider second mesh equation, that is, if you want to write the second mesh equation, then this I2 current is more than I1. Simple. So no need to each and everything. No need to apply KCL and find the current expression. Not required. Okay. So simply, if you want to write a second mesh equation, that current is more than first mesh. If you want to write first mesh equation, that current is more than second mesh. That's it. Okay. So from this you'll get first mesh equation. Now I have to write second mesh equation. So for that, let's consider the second mesh. Right. Now consider second mesh here. See, this is the second mesh equation. Right. So here, if I consider second mesh, means this current is more than any other mesh currents. That is the meaning here. Now apply KVL here. So apply KVL here. So first find voltage across 2 ohm resistor. So 2 into I2. Voltage across 5 ohm resistor. 5 into I2. Now voltage across 6 ohm resistor. That means 6 into I2 minus I1. Very, very important. 6 into I2 minus I1. The reason is this current is more than any other mesh currents. That is our assumption. Okay. That's why here 2 into I2 plus 5 into I2 plus 6 into I2 minus I1. Right. So from this you'll get second mesh equation. What is the final step here? Step number 4. Solve the system of simultaneous equations, okay, by applying Kirchhoff's voltage law, okay, by the application of KVL. Right? Now solve these two equations. Solve equation 1 and equation 2 to find the values of I1 and I2. Simple. Right? That is regarding mesh analysis. Okay. Now we need to discuss a few more points in this. For example, so these are our assumptions here, I1 and I2. For example, sometimes they'll give current direction like this. For example, like this. So this is I1 direction, that is anti-clockwise direction. Here in mesh 2, I2 direction. Okay, in mesh 1 clockwise, anti-clockwise, in mesh 2 also anti-clockwise. Okay, that time also your current value is I1 minus I2, same. That time also current value is I1 minus I2 or I2 minus I1. Please remember. That time also we'll consider subtraction. We'll write a subtraction only. Okay, and this is first case, clockwise direction. Both are clockwise direction. So this one is both are anti-clockwise direction. In both the cases, you'll write I1 minus I2 only. I1 minus I2 or I2 minus I1. Okay, I'll take a subtraction only. Please remember. So another case is mesh 1 current is clockwise, mesh 2 current is anti-clockwise, for example. Okay, so both the directions are opposite, for example, in some cases. Okay, if the examiner will mention directions, then no problem, not an issue. Okay, sometimes an examiner will mention like this: one is clockwise, another one is anti-clockwise. That time, say like this: both are opposite direction here. So opposite direction means here, what is the I here means I1 plus I2. Very, very important point, this one. I equal to I1 plus I2. Please remember this point. If current directions, if message directions are opposite, then you need to you need to consider addition. Okay, both directions are same, like whether it is clockwise or anti-clockwise, both are same directions means I1 minus I2 or I2 minus I1. Okay, you need to consider subtraction. Both are opposite direction means you need to consider addition. Please remember this point, very, very important. Okay, right. So this numerically belongs to two mesh equations, right? Let us consider three mesh equations. This three mesh circuit. Right. So three mesh equations. See, here question is find the current passing through 3 ohm resistor, current passing through 3 ohm resistor, and voltage across 5 ohm resistor. That is the question. Okay, so this is the question, right? That means here, now here also same thing. So already mesh currents are already assigned. So we need to calculate a number of mesh equations. So okay, so first two test steps are completed. That means step number 3 is apply KVL to the each and every mesh of the network. That is the step number 3. Let us assume first mesh equation. So let us assign first mesh current is I1. Now write the KVL equation of first mesh. So what is the KVL equation of first mesh here? Right. So according to KVL, now consider first mesh equation. I want to write first mesh equation. So according to this equation, first current enters negative terminal. So minus 30, next enters. So this is the current according to current direction. Current enters again positive. So plus 6 into. Now very important point here. This 6 ohm resistor is common in between first mesh and third mesh. That's why here in this element, two mesh currents are flowing. One is I1 mesh, that is first mesh. Another one is third mesh. So I1 minus I3 or I3 minus I1. But here I consider first mesh. That's why this current is more than any other mesh currents. That is the logic. So 6 into I1 minus I3. Next, plus 3 into, again, this element is common in between first mesh and second mesh. That means 3 into I1 minus I2 equal to 0. This is the first mesh equation. Very simple. Okay. So next one is, now let us write second mesh equation. See, now consider second mesh. This is second mesh. So according to current direction, first current enters positive terminal. That means across passive elements always current flows from high to low. That's why plus 3 into, now this 3 ohm resistor is common in between second and first mesh. Very important. So 3 into So what is the current here? Current flow I2 minus I1. The reason is now I want to write second mesh equation. If you consider second mesh, then that mesh current is more than any other mesh currents. Okay, that means here 3 into I2 minus I1. Okay, 3 into I2 minus I1 plus, so 5 into, now here this 5 ohm resistor is common between second mesh and third mesh, right? But here I consider second mesh. That means I2 minus I3. So I I2 minus I3. Next 6 into I2 minus I3 plus 15. Second current direction plus here current enters positive terminal. That's why plus 15 equal to 0. Okay, this is the mesh 2 equation. Now let us write mesh 3 equations. See mesh 3 equation. So according to current direction, this is the current direction. According to I3 current direction. See, what is the mesh 3 equation here? So first one is 1 into I3. First mesh equation is 1 into I3. Next minus 2. Next plus 2 into I3. Plus 2 into I3. Next plus 6 into, okay. Now this 6 ohm resistor is common between third mesh and second mesh. That means, and another thing is now I consider third mesh equation. I have to write third mesh equation, right? That's why this mesh equation, that is third mesh equation, is more than any other mesh equation. That's why 6 into I3 minus I2. 6 into I3 minus I2. Okay. So now consider 5 ohm resistance. So plus 5 into, again, I3 minus I2. Okay, plus 6 into, now here the 6 ohm resistor is common between first mesh and third mesh, but here we want to write the third mesh equation. We are writing third mesh equation, right? That's why this mesh current is more than any other mesh currents. That's why here I3 minus I1. 6 into I3 minus I1. I3 minus I1 is equal to 0. This is the KVL expression. This is mesh 3 equation. Now solve mesh 1, mesh 2 and mesh 3 equations, okay, for finding the values of I1, I2 and I3. So I request everyone better to use calculator to calculate I1, I2 and I3 values, right? So this is regarding mesh equations, right? So if you have any doubt in this, please put your doubt in chat box. So through chat box, ask me your doubt, right? So bye everyone. Have a nice day. This I'll end my session.